Assalamualaikum warahmatullahi wabarakatuh and salam UiTM di hatiku. In this video, our team will present a case study on gas chromatography analysis of essential oil. Without wasting any time, let's get started.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati Shazwani binti Muhammad Nurul Anwari, and now I will be starting off the case study with the objective. Firstly, the objective of this case study is to observe the organic compound in this essential oil, and also it is to determine the organic compound based on its retention time. What is meant by gas chromatography? Gas chromatography is a group of analytical separation techniques that use to analyze volatile compounds in gas phase. There are two categories of gas chromatography, and the first one is gas solid chromatography, where the stationary phase used is solid, and the other gas chromatography categories is liquid chromatography, which the stationary phase used is liquid. Gas liquid chromatography is more frequently used than gas solid chromatography. To utilize gas chromatography, there are two phases involved in this chromatography. Stationary phase is the fixed phase where it is used to determine the retention time of organic compound in analyte or sample. The other phase involved in this chromatography is mobile phase. The mobile phase for gas chromatography is in form of gas that contain both analyte and solvent, and it is also known as carrier gas, which carrier gas must be inert so it will not be reactive with the sample or analyte. There are 6 basic components in gas chromatography machine. It includes injection port, separation column, carrier gas flow control equipment, ovens and heaters, data acquisition system, and also detector.
I will present the methodology and sample preparation of essential oil. The method that we will use in this analysis is isolation of the essential oils. The essential oils were isolated according to the Likers-Nickerson method, using a microsteam distillation, which is the extraction apparatus for organic solvents lighter than water. As for the materials for this analysis is dried aromatic plants, marjoram plant, and pure commercial essential oil components. And for the apparatus consisted of a main body, a cold finger, a 100 ml water flask, and a 5 ml solvent flask. Now, I will explain about the sample preparation of essential oil. 4 ml of the extracting solvent diethyl ether was heated in the solvent flask and condensed on the cold finger above the place where the water condensed. 10 grams of the sample to be analyzed was heated in the water flask with water. Next, the vapor, which also contained the volatile organic compounds, condensed on the cold finger. Both phases returned via the connecting tubes into their flask, and the procedure was started again. Refluxing was continued for 2 hours. In that way, all of the aroma constituents concentrated in the extracting solvent. Inert gas nitrogen was introduced into the main body of the apparatus to avoid the oxidation of molecules during the procedure. All diethyl ether extracts were stored at 4 degrees Celsius until their analysis by GCMS or their uses in bioassays. Next, I will explain about the procedure using gas chromatography machine for all essential oil. The analysis of all essential oils was performed using a Hewlett-Packard 5890 gas chromatography equipped with a HP5 capillary column, and a mass spectrometer is 5971A as a detector. The carrier gas was helium at a flow rate of 1 ml per minute. Column temperature was initially 60 degrees for 5 minutes, then gradually increased to 160 degrees Celsius at 4 degrees Celsius per minute, and finally increased to 240 degrees Celsius at 15 degrees Celsius per minute. For gas chromatography, mass spectrometer detection and electron ionization system was used with an ionization energy of 70 watt. The extracts were dilute 100 with diethyl ether and 1.0 microliter of the diluted samples was injected automatically in splitless mode. Injector and detector temperature was set at 250 and 280 degrees Celsius respectively. Now, I will continue with the procedure using gas chromatography machine for analysis of marjoram essential oil. Marjoram essential oil analysis were performed using a Phison 8000 gas chromatography machine equipped with a CP-SEAL 8 capillary column and mass spectrometer 800 as detector. Column temperature was initially 60 degrees Celsius for 5 minutes, then gradually increased to 240 degrees Celsius at 4 degrees Celsius per minute and keep there for 5 minutes. In this case, 1.0 microliter of the diluted sample was injected manually in splitless mode.
Hi, my name is Anis Irina Binti Aziz, and I'll be talking about the result and discussion for this experiment. For the result, the table shows quantitative composition of the essential oil for the lavender. The composition percentage from all the components are as follows. A hydrocarbon called B-caryophyllene will have a percentage of 0.3%. Linalool with a percentage of 44.5%, Borneol with a percentage of 3.9%, terpineol with a percentage of 6.9%, and alpha terpineol with a percentage of 3.5%. These components that I had said before were alcohols. After that, the ether called 1,8-cineol has a percentage of 4.8%. And lastly, the ester called linolyl acetate have a percentage of 32.7%. For the discussion, authentic samples and mass spectra from the data libraries were used to determine the composition of essential oils for lavender. The essential oil is characterized by the presence of one or two substances in predominant amounts. From the result in the previous table, linalool with a percentage of 44.5%, linolyl acetate with a percentage of 32.7%, and 1,8-cineol with a percentage of 4.8%, which makes up to 82% of lavender essential oil's chemical composition are the major components. These major chemical compositions were also found as the main components of lavender oil by Sedatian et al. For 2013, except that in their study, 1,8-cineol percentage is higher instead of linolyl acetate. The other general component is camphor.
In conclusion, the objective of this case study has been achieved. The organic compound found in the essential oil consists of hydrocarbons, alcohols, ether and ketones, and also esters.
I will continue our presentation with sharing the additional information of essential oil. Essential oils has the ability to treat certain health conditions. First, stress and anxiety. It has been estimated that 43% of people who have stress and anxiety use some form of alternative therapy to help relieve their symptoms. Many have shown that the smell of some essential oils can work alongside traditional therapy to treat anxiety and stress. Next, headache and migraines. In the 90s era, two small studies found that dabbing a peppermint oil and ethanol mixture on participants' foreheads and temples relieved headache pain. What's more, it has been suggested that applying a mixture of chamomile and sesame oil to the temples may treat headache, and migraines. This is a traditional Persian headache remedy. Third, sleep and insomnia. Smelling lavender oil has been shown to improve the sleep quality of women after childbirth, as well as patients with heart disease. There is one review examining 15 studies on essential oils and sleep. The majority of studies showed that smelling the oils, mostly lavender oil, had positive effects on sleep habits. Lastly, antibiotic and antimicrobial. The rise of antibiotic-resistant bacteria has renewed interest in the research for other compounds that can fight bacterial infection. Test tube studies have investigated essential oils such as peppermint and tea tree oil extensively for their antimicrobial effects, observing some positive results. However, while these test tube study results are interesting, they do not necessarily reflect the effects that these oils have within your body. They don't prove that a particular essential oil could treat bacterial infection in humans. That's all from me. Thank you.